Hello and welcome to the second video on C1 and C2 for GCSE chemistry revision. In this video we're going to have a look at mixtures, solutes, solvents and solutions, filtration, crystallization, distillation, fractional distillation and paper chromatography. Now to start off with, I would like you to answer these three questions and ask your teacher to pause the video, please. Should now be ready to mark your answers. Well done for getting all of those correct. We're now going to begin the session. So first up, we're going to have a look at mixtures. And what is a mixture? It's just two or more elements or compounds that are not chemically bonded together. So we will have a little look. So I've got a beaker here. In my beaker, I've got some water. It's just pure water. So each one of these is a water molecule. It's the only thing that is in here. This is not a mixture because it is just water. It's only molecules of H2O. I'm going to draw another one, so I'm going to have my water again. I've got my water in there. But this time I'm going to add some sugar, or so add some salt into it. So we've got our Na plus ions and our Cl minus ions. Na plus ions and our Cl minus ions. This now is a mixture because we have two or more compounds that are not chemically combined. Because there's no fixed composition, so we can have any amount in there, we have varying amounts of each one in there, and there's no chemical bonds between the different elements or compounds. We can use physical methods to separate the elements and compounds. We're going to have a look at those in this video, but first some questions. Please pause the video and answer the questions. You should now be ready to mark your answers. Check your answers and change anything that you got wrong. So first off, we're going to have a look at some of these key words and what they mean. We've got the word solute, solvent, and solution. Now I'm going to draw a beaker again, and inside it I've got water. I've just got pure water. So we've got water, which is H2O. Let's draw some H2O in there so we know that it's H2O. Now into my water I'm going to add a tablespoon of salt. I'm going to add it in and give it a mix around. So I end up getting my water, which was just pure water at the start, and then we'll say I've got sodium chloride in there as well. And my sodium chloride ions break up and are dissolved in there. Now you might be thinking, okay, I know that, I put salt into water, stir it around, and it dissolves. And that helps us look at our key words that we've got here. So we've got my salt here. This is my solute. So my solute is the thing that I am adding into a liquid. It's the substance that will dissolve in a liquid. So it's my substance that dissolves in a liquid. My water, or my liquid, this is my solvent. This is my liquid that will dissolve my solute. If I put a solute into a solvent, I get, in this case, I get salt water. Obviously, generally we can call it lots of other things. We get a solution. So a solution is a solvent, a solute dissolved in a solvent. And this is generally going to be aqueous. It has something dissolved in it. Now please pause the video to complete these practice questions. You should now be ready to mark your answers. The answers are on the screen now. We're now going to have a look at something called filtration. And starting off, we've got our definition of what filtration is. So filtration is a separation technique used to separate an insoluble substance from a liquid. So what I have here is a beaker filled with salt water, and my salt water is a solution. The salt, the sodium chloride, has dissolved in it, and I have some sand at the bottom. My sand is insoluble. Now I'm going to want to separate out the water, the salt and the sand into three different parts. To do that, I'm going to need to filter my solution with the sand in it. To filter it, I need a beaker, I need a funnel, and I need some filter paper. I'm now going to take my solution and sand and I'm going to pour it into here. And what we see happen is that my salt water will pass through. That'll be my water molecules, and my sodium and chloride ions will pass through because they are small. My sand, however, will be kept in the filter paper. The molecules of the sand are too large to pass through the filter paper. So I now have my salt water has been filtered through. This is known as the filtrate. It's been filtered through. My sand, on the other hand, has stayed up here and is known as my residue. So filtration shows us how we can separate an insoluble substance from a liquid. Please pause the video now and answer these 6 questions. You now should be ready to mark your answers. The answers are on the screen now. We're now going to have a look at another separating technique. That separating technique is crystallization. Now, crystallization is a separation technique used to separate a dissolved solute from a solvent. So I have here my salt water that I collected earlier when I filtered my salt water that had sand in it. I now want to separate out the water and the salt. To do that, I'm going to use a process called crystallization. I'm going to take my water and I'm going to put it into an evaporating dish. So I have an evaporating dish, which is a shallow dish that I can use to hold water. It's made of ceramic. I'm going to pour some of this liquid into it. Now I've poured it in here. There are a few things I can do. I can either leave it in a warm sunny space, or I can heat it using a Bunsen burner. I'm going to leave it on a warm, sunny space, and as I do that, if I leave it for a few days, I start seeing, or I don't see, but I start noticing that my water has gone. My water molecules begin to evaporate. So my water will evaporate. My salt does not evaporate because my salt has a higher boiling point than water. In this case, or generally speaking, my solute has a higher boiling point, so will not evaporate. So will not evaporate. And it gets left behind as crystals. Now there are times if we want to make larger crystals or smaller crystals. To make a larger crystal, there are two things that we can do. We can saturate the solution. So we can saturate the solution. And when I say saturate, I mean that we can add no more of the solute into the solvent. We keep adding more and more of it in until it stops dissolving. We saturate the solution, we get larger crystals. Also, the longer it takes to evaporate, the larger crystals we get. So both of these give us larger crystals. So please pause the video now. You can answer these three questions. The answers are on screen now for you to mark your work. We're now going to have a look at distillation and fractional distillation. Distillation, first, is used to separate a solvent from a solute. Now you might remember our solvent is our liquid, and our solute is the thing that's dissolved inside it. Now to do that, we need to use some specialist equipment. So I have my equipment set up here. I have a round bottom flask. Inside my round bottom flask, I put my solution. Inside my round bottom flask, I have anti-bumping granules. Now these have a very useful tool. They allow the boiling to go smoother. We want smooth boiling. That means we don't get any large bubbles being formed and reduces the risk of the solution boiling over. Now, as I heat my solution, my liquid will boil and it will rise up. It will become a gas and it will pass all the way up through this column. We'll then go down through this sidearm. This sidearm, I have this lovely bit here called a condenser. My condenser allows water to go in through the bottom and come out from the top. My condenser does what you think it does. It condenses. When we condense something, we turn from a gas to a liquid. We'll then get what we had as a gas now coming out from here, and we can collect it down here. We do have a thermometer here as well. The thermometer allows us to check the temperature. We know the temperature that the solvent will boil at, We can check that it is the same temperature. Next up, we're going to look at fractional distillation. Now that is used to separate substances with different boiling points. So I can use this to separate substances that have different boiling points. So crude oil is separated using fractional distillation. Alcohol is as well. Now I've got a few extra parts on here. I'm now going to call this my fractionating column. It has glass rods inside. And those glass rods have a very, very useful purpose, which we'll look at in a second. So I have my liquid in the bottom, and it is heated using a Bunsen burner. As it is heated, or an electric heater as well, as it is heated, the liquid with the lowest boiling point will boil first and will rise up the fractionating column. At the top, I have a thermometer. My thermometer is there to check the temperature. If I know the boiling temperature of my liquid, it reaches that temperature, I know that is what is coming out. Now, as my liquid is boiled, the liquids will boil and turn into a gas. They'll rise up. These glass rods increase the area available for condensation. It's up. We have a hot temperature at the top and a colder temperature, hot temperature at the bottom and a colder temperature at the top. Once a liquid reaches a point past its boiling point, it will go back, it will condense back into a liquid and flow back down to the bottom again. And we will continue until only at the top do we have the liquid with the lowest boiling point. That will then pass through the condenser and can be collected in here. As we continue to heat it, the temperature rises. The temperature on the thermometer will rise as well, showing that rise. We can then recognise that we have a new liquid being boiled once it has risen above that initial boiling point. We can then swap out our collection beaker and collect the next liquid given out as well. And we can continue this until all the liquids have been separated. So please pause the video now and have a go at completing these questions. The answers are now on the screen. The last thing we're going to look at is paper chromatography. So that is a separation technique used to separate compounds into their individual components. So I have here my setup for chromatography. I've got my solvent, which could be water or ethanol, any liquid, a beaker, which I've kept it all in, and my chromatography paper. What we then do is we draw a starting line in pencil. So we have a line in pencil. The reason why it's pencil is because pencil is insoluble in most liquids, so will not move up the page. We can then place our samples along the starting line. And we will see the solvent move up the paper. It will carry the specimens or the compounds with them and divide them up into different places along here depending on how soluble they are. The further it moves up, the more soluble something is. Colours can also be split into different compounds as well. So we might find that our red one comes to here, our yellow one comes up to here, our green one is made of blue and yellow. We've split it down into colours and our blue one will move up to here. And we can see that we've got different results. Our red one is the least soluble, our blue one is the most soluble, and our green one is made up of 2 different colours. We have a few more key words to learn here. Our solvent is also known as our mobile phase. It is the part that is going to move in chromatography. It will move up the paper. Our chromatography paper is known as our stationary phase. It will not move at all. It's the only thing within chromatography that will not move. Please pause the video to answer these last 2 questions. The answers are on screen now for you to answer. Thank you very much for watching. I hope you've had a good day. Take care and stay safe. Bye-bye.